Well, howdy there, Internet people. It's Professor Leach again, and today we're going to talk about learning to read expressions. I don't like invoking the phrase order of operations because people immediately start thinking of PEMDAS, and PEMDAS is trash. It's not wrong because it'll give you wrong answers. It's wrong because it's morally wrong. It treats you like a computer, and you are better than that. But to learn to properly execute our operations, we need to learn how to read expressions. I don't have any empirical evidence for this, but I think this learning to read expressions is the important part of the algebra class. I think too often we look for shortcuts that we try to take when we're reading the written word or the printed word, well, the written word, that are not really available to us when we're trying to read mathematics. So keep in mind that when you're reading this sentence, even though I wrote it kind of messy, you still know what the words are because your brain has immense subconscious processing power that you're not even seeing the letters in here. I could have misspelled every single word in this sentence and you'd have still been able to get the message. It's not about reading the letters, it's about seeing the whole message. Math, it's harder because math is a much more precise language. Our spelling errors will change the meaning of the expression. So let's take a look at this expression. Before we went on that little pause, I asked you to speak this expression without just spelling that. So you can't just say 3 parentheses x minus 5 parentheses squared. That's just spelling it, and THAT''S ISNOTHOWWECOMM communicate. I can't spell communicate on the fly like that without looking at it. That's not how we communicate. We don't spell things at each other, except in very strange circumstances where we encounter a new word. So let's look at some of your expressions. I'm going to write the things that you wrote. I'm going to write the expression that you wrote in the text. Now, if you're thinking, all right, it sounds like he's going to deliberately get this wrong. You're absolutely correct. That's the game that we're playing today. Leach gets stuff wrong. But it's going to be a valid expression based on what you've written, because we haven't made this agreement yet. We're pretending like I don't know that this is what you're trying to communicate. So take x minus 5 and square it. Take x minus 5 and square it, then multiply it by 3. No, that's like x minus 75. Usually people use a lot of the word it, and it is never going to be a good word in these kinds of expressions. So when you say 3 times parentheses x minus 5 parentheses, you're just spelling. So this one was, the language here was take x minus 5 This was the downfall. What does the it refer to? It could refer to the 5. Does it refer to the minus? We don't put a square on a minus symbol. What does it refer to? So hard to see what that refers to. Then multiply it by 3. Same problem there. Not making fun. Like I said, this is a thing that is hard to do. And it's a very precise language that we're trying to speak. When you say 3 times parentheses x, that's just spelling. That's just spelling what's going on. Spelling is useful in certain situations because when I introduce myself as Evan, there's this little pause before they have to type it in, and I stop and say EVAN. My name's becoming a little bit more common, so I have to do that less and less, but I went through the 70s with that name, so I had to spell it a lot. I hope I got it right. Let's see. 3 times x squared minus 5 squared. 3 times x squared minus 5 squared. This is not that expression either. This was 3 times x squared minus 5 squared. We can't just square the two terms because exponents do not distribute over sums. So I can't write an equivalent version of this where I just square the two terms. That's exponents do not distribute over sums. Also, I might read the same thing, 3 times x squared, 3 times x squared minus 5 squared. So there's a little lack of clarity there about what we mean. Any questions? Sometimes I wonder if this is hard to do because the word literally does not literally mean literally anymore. It's used for emphasis. It's just become an emphasis. So I know some people are going to die on that particular grammar hill, and I'm not saying that I don't have my grammar hills that I'm going to die on, but literally has become just emphasis. I am literally dying right now. Just means things are really funny, I guess. You know what I mean? All right. So it's really hard to look at this and make someone else write exactly this, especially if they're going to deliberately try to get it wrong. We have to say it like we're going to court. And we're going to say this in court, and there's not going to be any chance that someone misinterprets what we say. We have to come up with a way to say it that way. Let's think about what happens in this expression. Let's maybe think about what happens in this expression. If we were going to evaluate this expression for some number, for some value we put in for x, what are the things that we do to the x to evaluate this expression? What happens? The way I usually ask this question is I say, what happens? Let's think about what happens to the x when we evaluate this expression. That is to say, what operations do we perform, and in what order do we perform those operations? I should have just led with that, but what happens to the x when we evaluate this expression? That is, what operations do we perform, and what order do we perform those operations? So if you were going to plug a number into this expression, what is the first thing that you would do to that number? What is the first operation you would perform? Let's say x is equal to 12. What's the first thing you do to the 12? And I'm going to abbreviate what it means, that what we write down, what operations we perform down here. I'll list them in order. First, x is 12. What's the first thing you would do in this expression? Multiply by 3, square things, subtract 5. What goes first? It's okay to rely on the order of operations that you learned about in the past, but make sure that it matches the things that we've talked about as far as operations go so far. So parentheses, that's good. That's our PEMDAS. That's PEMDAS saying parentheses is the first operation, but parentheses is not itself an operation. Parentheses just is what is language that we use, or notation that we use to change the order of operations. Multiplication goes before addition unless parentheses. Exponents go before multiplication unless parentheses. So when you say parentheses, what do you mean? Because I see some things attached to the parentheses 3 times. I see some stuff being squared inside the parentheses. I see subtracting 5. So what would you do first in this expression? Minus 5. So I'm going to put down here, I'm going to say the first thing we do is subtract 5. Excellent. If there's a 12 in here, you think parentheses first. That means do this. The parentheses say do inside here first. So 12 minus 5, that would be 7. So after we have the 7, we've got 3 times 7 squared. So what would the next thing we do? After we subtract 5, what's the next operation that we perform? We've taken care of the subtracting 5. We've still got 3 multiplied by 3 and taken to the second power. Which of those do we do first? Do we multiply by 3 first, or do we exponent first? What goes first? So if we think about it with numbers, we're going to do the exponent first. So we have 12 minus 5, that's a 7. So I've got 3 times 7 squared. Exponents go before multiplication unless parentheses. I don't have parentheses around the 3, so the exponent only applies to the x minus 5. So the next thing we do is exponent. So I'm going to say to the second power. I'm just going to write the operation I'm doing and then how much I'm doing that operation. And then so once we take care of the exponent, what's the last thing that happens in this expression? Just following my funky Leachian notation down here. What's the third thing? It's the only thing that's left. So 7 squared is 49, and the last thing we have to do is multiply by 3. So I'm going to make a notation. I'm going to multiply by 3. Those are the 3 things that happened. If I want to simplify this expression and I plug in a 12, so if, for example, I'm saying x equals 12, the first thing we do is subtract the 5. So 12 minus 5, that gives us a 7. The 7 is still having to be squared, and there's still some multiplication by 3. The second operation that we perform is we do the exponents, because exponents go before multiplication. 7 squared is 40 something. This is still being multiplied by 3. And then finally, we arrive at 3 49s, which is 127. So 147. That's just how I multiply. I do it in parts. So here we are following the order of operations. Oh, whoops. I was trying to color match things. There we go. Redraw the box. So we identified the order, the operations that we're performing, and the order that we perform those operations. Now, if I write a different expression with just move the parentheses around or move the operations around, I can write a different expression that still involves multiplication by 3, raising to a second power, and subtracting 5. For another example, I'm going to do it over here. For another example, what if I write the expression 3x minus 5 squared? What order do we perform operations in this example? So what's the first thing that would happen? It's still, notice this is still the same 3 things. There's multiplication by 3, there's squaring, and there's subtracting 5. And what we're trying to do is, even though you instinctively know what you're supposed to do, I need to know that we know why we're doing those things. So multiply x, you got to pick one. We got to pick one. Which one goes first? X is a 12. What's the first thing we have to do to that 12? Square it, subtract 5, or multiply by 3. There's exponents, but there's also parentheses, and parentheses say do things in the exponents before multiplication unless parentheses. multiplication before addition unless parentheses. If we plug a number in for the x, what's the first thing that happens to it? Subtract 5, multiply by 3, or second power. If we're not sure, let's pick a number for 12, for x. So for example, what if I said x is equal to 4? What's the first thing you would do to simplify this expression? 3 times 4 minus 5 squared. First thing that happens, multiply by 3. So that's the first thing. Let's make a note of that because we're trying to analyze things. We're really trying to get it into the weeds about what's going on. So after we multiply by 3, 3 times 4 is 12. And then I still have the rest of the expression surrounding it. Now in this expression, what's that? We got to 12. What's the next thing that we do? What's next operation that we perform? We've done the multiply by 3. Do we square things or do we subtract 5? Are we ready to square things here? So exponents will go before multiplication, and multiplication goes before addition unless parentheses. So exponents should go before subtraction unless parentheses. So we see this exponent, and we also see minus 5, but we want to subtract 5 next because parentheses are telling us to do that. So the next thing is subtract 5. Great. So 12 minus 5 is 7. And then what's the last operation we need to perform? It's the only one left. We raise to the second power. 7 squared is the 49. It's the same 3 operations, but we perform them in a different order. In the expression that we wrote first, 3 parentheses x minus 5 close parentheses squared, it's subtract 5, then square, then multiply by 3. In this expression, I'm just going to spell it, parentheses 3x minus 5 close parentheses squared, we multiply by 3, then we subtract 5, and then we square. I don't know if diagramming sentences is still a thing, but what we're doing here is looking at this expression like a sentence in English and diagramming it, identifying the subject, the verb, the object, any prepositional phrases, breaking them down into the preposition, and I can't remember what the other parts are. I don't know if they have names. If they do, I can't remember them. The minuend and the subtrahend. Okay, that's cheating a little bit. But we're just analyzing very carefully what we almost would do instinctually. And I saw this happen. Because I'm like, oh, evaluate this expression. I had a quiz like that. Evaluate this expression for 4. And then you're like, oh, 49. And I'm like, oh, show your calculations. And you're like, oh, 49? Because you were doing things instinctually before because you were relying on old programming. Now I'm making you think about what this expression is telling you to do. Reasons for that. One of the reasons that we want to be able to do this is that if we want to speak this expression, if I wanted to read this expression, maybe you'll see the trick that I'm employing. I would read this. If I wanted to make sure that you wrote exactly this, I would say write the square of the difference between 3 times a number and 5. And this would be the only thing that you could write. If I wanted you to write this expression, I would say take 3 times the square of the difference between a number and 5. And this would be the only thing that you could write. Moreover, if I wanted to solve an equation, if I knew that the 4, right now we know that 4 turns into a 49. If I want to undo what happened to the 49, this little roadmap, I could just follow it backwards. I just click the button that says reverse these directions. And I would start off by taking the square root of 49, that's the inverse of a square, come up with 7. And then the inverse of subtracting 5 is add 5 to land at 12. And then the inverse of multiplying by 3 is divide by 3, and I would be back up at the 4. Multiply by 3,
subtract 5, square. The inverse of that would be square root, add 5, divide by 3, and get you back to 4. Over here, same thing, or different operations. To get from 12 to 147, we subtract 5, then we square, then multiply by 3. If we wanted to go the other way around, we wanted to reverse this, like say solve an equation, we would first divide by 3, that's the inverse of multiplying by 3. Then we would square root, that's the inverse of squaring, land at 7. And then we would add 5, that's the inverse of subtracting 5, and be back to the start, 12. It's a roadmap for how to solve the expression, or sorry, solve an equation. It's also a roadmap of how to speak this properly. It's also a roadmap of how to, about when we start talking about functions and inverse functions, how to construct an inverse function. The inverse function will be the square roots, then minus 5, and then dividing by, or then adding 5 and then dividing by 3. All this comes from reading what happens in the expression. Now, this is not stuff that we want to write down every single time, because look how time consuming it was. And someone is surely going to come along to this video and say, oh, yeah, I could evaluate this expression for much faster than doing all this stuff. It's 49. But like I said in previous videos, or in previous lectures, I'm already turning into a YouTuber. Ugh. Like I said in previous conversations, it's not about speed, it's about understanding things so that you can be flexible. Because if we want to be fast, if you start arguing from, I can do it by hand faster than you, it's like, oh, what if your hand is using a calculator? That's going to be faster still. And also, that's just missing the point. And for the most part, when people are missing the point, I think they're doing so deliberately because they're doing what's called arguing in bad faith, in which case they should just be ignored. Any questions? So, if you out there on YouTube randomly happen in this video and you're offended because you think you could do math fast and that there's, just teach them the old way, just teach them the way that I did. Your arguments are trash, and I'm just going to block you. That's not actually going to be a problem. No one comes to these videos except for people who are in this class. So I feel pretty safe. But for the rest of you, go ahead, come at me, bro. We'll start by comparing expertise. Any questions? So remember, this is not about speed. It's not even about me. It's not even a problem that I'm going to ask you to do. I'm not going to say, write a sentence that describes, I might. Honestly, I might. But it's not that, that's not the point of what we're trying to do. We're just trying to reinforce our understanding of how these operations interact. Exponents go before multiplication unless there's some parentheses. Multiplication goes before addition. Notice that in the 3x minus 5, we did the multiplication first and then subtraction because there were no parentheses. But up here, this multiplication came after the subtraction because parentheses. So that's Leach's order of operations. Exponents before multiplication unless parentheses. Multiplication before addition unless parentheses. And this before stuff is transitive. So exponents before addition unless parentheses. Fits together better. And it treats you like a thinking human being that's trying to understand something rather than a robot who's just trying to crank out numbers. Any questions? Comments? Deep thoughts? Cool. I know this was a lot of blah, blah, especially on a Friday. And there's a little, and I warned you up front that I was deliberately going to misinterpret the things that you were saying. It's okay. I think it's okay to argue in bad faith when you're just playing a game. You know what I mean? So I'm just like, it's like, oh, well, that's not what you said. Because honestly, if you're in an argument with someone, and they come back at you, it's like, oh, well, you said, and then they actually just quote you, you're on your way to winning. Because they've just had to retreat from making a point into semantics. The next thing that comes is the ad hominem attack. That means they attack you personally. As soon as someone attacks you personally in an argument, you don't have to respond anymore. You've won. So as soon as it says, well, your hair is terrible, then you just say, thank you, I accept your surrender. You concede my point and I was correct. Because they got nowhere else to go. You know what I mean? Anyway, it's just a thought. Y'all have a good day.